Thank you all very much for coming to the Google Chrome Fireside Chat. My name's Ian Fette. I'm a product manager on Google Chrome, and I'd like to introduce everyone else up here on stage. We've got Alex Russell, one of the software engineers on the Google Chrome team, Brian Rakowski, Director of Product Management for Google Chrome, and Erik, also a software engineer on the Google Chrome team. I think we'd like to keep this sort of informal. I'm a big fan of just Q&A style sessions. So there's a mic in the middle of the room. If you have any questions for the panel or for any of us, please come up to the mic in the middle of the room and ask away. Will we accept shouted questions from the sardines in the middle of rows? Yes, but if someone is at the mic, they will get priority. That was easy, thank you.
I'm at the mic. I'm going to try and phrase this statement as a question. Today you announced the Google Chrome App Store. In the same conversation, almost the same breath, as talking about all the openness and things like that. Can you connect those two in an open way?
Sure. I'll take a stab at this. So think about the web apps that are going to be on the web store. They're really just web apps. They're the same web apps. The only difference is that we're providing a little bit of glue, a little bit of metadata to describe those apps. So existing web app runs on any modern browser. Tack on a little bit of metadata that allows it to run a little bit nicer in the browser, that allows the listing to show up in the store. That's all.
So when I buy an ad, where does the permission model key into that, and how does it, is it locking it into Chrome, or if I'm running Chrome and I'm also running Safari, I can run the same app?
So if you want to sell web apps, the thing that you're using there will be our backend license server. So at that point, this is again just web app talking to web server, and so that technology should run, on any browser.
Okay, thanks.
Open mic at the floor, please step on up, don't be shy.
I'll follow on to that with a shouted question. So I went to look immediately after you announced this and discovered that the only way to start developing is to use the Windows build with a certain command line flag, which immediately leaves those of us using a different platform as our primary development platform.
Sure, let me repeat the question, since it was a shouted question. The question is, well, if you went to check it out today, you can only try it out on Windows, and that kind of sucks for everybody using Mac or Linux. And yes, we're sorry. So, but let me give you a little bit of rationale for why it is this way. Chrome being an open source project is a blessing and a curse. So the blessing part of it is that, from your guys' perspective, hopefully, is that you get to see stuff really early on. We don't really get to keep secrets for very long, because we have reporters who are literally monitoring our source check-ins. So basically, people were going to figure this out before too long here anyway. So what you're catching us is in the stage where we're still iterating on the UI and still trying to make decisions. Now, typically in the development cycle, we do our prototyping on one platform, and depends on the team, depends on what they're doing most of their development on. But since we're making lots of changes and lots of stuff, it doesn't make sense to do that 3 times until we're a little bit closer to being for sure this is it. We do have some early work happening on Mac. I think we're not that far away from being able to have people play with it on Mac, but it just doesn't make sense for us to do it all together. But our plan is to have a developer preview for all the platforms later this summer. So anyway, you can hear more details about some of this stuff. There's a session tomorrow going into a little more detail.
Next question.
I was noticing that on the schedule, it says this is a fireside chat with the Google Chrome and Chrome OS team. Are we clear to ask Chrome OS questions? Can you guys answer those?
We actually don't have anyone from the Chrome OS team here. We have people all representing Chrome here. So you're welcome to ask questions. We may not give you
very interesting answers.
Okay, sure. Yeah, then I'll still ask my question. Just first of all, what is kind of the status of Chrome OS? I mean, I know there's been some. I've heard a little bit about it. I haven't heard too much buzz. I was actually kind of expecting to hear more today, especially with kind of there's been these massive overtones of HTML5 and the Chrome Web App Store, and now I just came from the NACL session with running native code in Chrome, and that all sounds great. And is all that going to be kind of incorporated into Chrome OS? And the other question I guess I would have is, what's kind of the timeline on that? I know Notion Inc. is coming out with their Atom tablet. They claim can run Chrome OS. And I think it was Acer or Asus is supposed to come out with a netbook that can run Chrome OS. Just what's the, and maybe you guys don't even know the answer to those questions, but just to kind of put them out there.
Yeah, I can give a quick answer. So in terms of the progress and a status update on Chrome OS, the team is continuing to make really good progress. It's all happening in the open source like the rest of Chrome. So, there's no secrets there, and everybody can check in and see what's happening. We don't have a lot of new things to announce right now. We're focusing what we're talking about on the stuff that people can play with today as developers, unless, of course, you want to plug into the Chrome OS development itself in the open source project. In terms of the schedule, I think things are moving along. We don't have any announcements in terms of products that are going to be shipping with Chrome OS, but as you know, there's lots of people who are downloading the source, compiling it, and sticking it on netbooks, so people are playing with it that way, but I certainly don't recommend doing that as a user. But as a developer, we're very excited to see all the momentum around it. So still very important. We're still chugging along on it. It's not, like forgotten or something like that. It's just not much to talk about yet right now.
And part of your question was around the native client session, around the web store. We're working very hard to make sure that everything we do in Chrome benefits Chrome OS and vice versa. So you see UI concepts that are first prototype on Chrome OS making their way into Chrome where it makes sense. All the work that we're doing in Chrome, like native client, the web store, all of that is available in Chrome OS as well. So we're trying to make sure that innovations that happen on either side of the product make it all the way around when that makes sense. And for native client and web store, that definitely makes sense.
Thank you.
As an enterprise customer for apps with about 17,000 seats, we're trying to move away
Could you
from...
step up to the mic?
Yeah, sorry. I'm an enterprise apps customer with about 17,000 users. We're trying to move away from IE6, and we'd like to take Chrome seriously. But without things like group policy controls and being able to create custom packages, we can't really do that. Is there anything in the works?
Yeah, so there is a series of group policy controls for Omaha, which is the auto-update system, which will today allow you to configure when and how Google Chrome is updated. So for those of you who don't know, Google Chrome continuously auto-updates in the background. So every time we push a new revision, it's out to 90+% of the user base, in months, not years. So you as an administrator can choose to today, through that group policy template, configure when those updates come down so you can lock it. As another potential option for you, I work on a product called Chrome Frame, which allows you to run Google Chrome's rendering engine inside of IE6. So in case you have applications inside your firewall that can't move just yet, you might not have to run browsers side by side.
We also have a group of engineers that are working on making more of the Google Chrome settings configurable via group policy. Some of those you'll see start to roll out in Chrome 6. So that's also ongoing work.
Very good. Thank you.
So before joining Mozilla, I was interested in the auto detection of extensions and web apps like that on the web in a way that's open. Recently there was a post on Mozilla Labs, I don't know if any of you caught it, about indexing extensions and apps, and I was just wondering, I would love to get your guys' feedback. We didn't really hear anything from any of the browser vendors, but we're going to start exploring it. So do you guys think that that's something you'd want to pursue, like an HTML sort of like, I know there's pseudo standards and meta tags and stuff like that, but go that direction?
Yeah, this is definitely something we're exploring. And, I don't think we have anything really specific to share, but there's sort of two ways you can look at it. So one is discovery on the pages that are, directly are the app, right? Saying, oh, I am a web app, or I have a related extension, that sort of metadata. The other thing, to be honest, is that, all the different galleries and stores and that are out there actually contribute a lot to search and discoverability that are out there. AMO for Firefox gets crawled, all of its pages. If you want to look for a Firefox extension that does XYZ, it's really easy to search in any search engine and find it, and the same with Chrome extensions. But I think that, I think that part is already in pretty good shape, but I think we should keep pushing on that having curated directories with reviews and rankings and popularity, these are all things that help make search better. But as far as discovery on the web, we think that's important too. The reason why that is important is to sort of help people have more accidental discoveries, connected things to the things they typically do. And I think there are a number of different approaches to that, aside from just the metadata thing, but I don't think we have anything concrete to share at this stage.
Okay.
The microphone is open if anyone has questions, or feel free to just shout it out. Erik, what's the payment mechanism for the web store?
I'm a popular guy today. Well, that's a good question. We're going to be using Google Checkout primarily. I think beyond that, we don't have a lot to share. It's something that we understand that basically today on the web, you can already sell things. And so we have to compete with what's already out there. So it's our intent to try to make a really smooth experience for developers and end users. And so this is a challenging thing to do for anybody, if anybody who's been involved in payment systems before knows. But we're intending to be as broad and deep as we can on that front. As I said before, you're catching us pretty early. I'm sorry, I should repeat the questions. So the question was, what's the rev share model for the web store, I imagine? So you're catching us pretty early in the process here because, like I said, the open source nature and some of the concrete business details like that, we have ideas for it. We're working through that, but we don't have anything definitive to share yet.
Hi, what challenges do you guys have as developers that we wouldn't think you would have? I mean, obviously one of them is everyone looking at every check-in you do.
We have to write in C++.
I think from my perspective, I should just caveat this. I manage the group that's working on all the HTML5 APIs in the web platform. I think a lot of people have this notion that now that Google has a web browser and a bunch of web applications, that it can just sort of go off and do whatever it wants to do. And it turns out that things are a lot more nuanced than that. We work very hard to make sure that the APIs that we develop give a lot of power to web application authors, not just at Google, but across the web as a whole. And so we have to do a lot of work to think, what is the right API for the web? Not just for Google, but for all web authors. We have to think about how does this fit in with other web standards. We spend a lot of time in standards bodies, and while we don't constrain ourselves, we don't require full buy-in before we do anything, before we innovate, it's certainly not the case that we just go off and do whatever it is that we want to do without any consideration for web standards, web communities, other developers. So I think that's something that takes a lot more time and effort than most people would expect, but in the long run, I think it's well worth it for us to do that.
So I think the thing that maybe people who are developers who've developed client code before might appreciate that I think is the thing I'm probably most proud of that the Chrome team has done is kind of something sort of deep and esoteric, which is that we release from the trunk every week, basically. So what that means is we're pushing out a new client build, from the tip of tree. There are no private branches. There's no, large efforts going on that people aren't seeing, that aren't getting pushed out immediately. And the fact that we're having to do that every week means that we have a lot of responsibility to not regress, to not introduce new performance regressions, to not break compatibility for some large number of sites, for not really messing things up when we add some new experimental feature. And for all the web developers in the room, you're used to this, that this is something you have to do all the time. In C++ land and integrating with OSs and all of that, this is something that I think has really never really been done before. And it's partly because of our auto-update mechanism, but also partly because of our development practices and engineering philosophy. But as a result, it winds up being quite challenging. You check something in, if you break something, your change will get reverted immediately. So there's people give you a hard time about it. And so you have to be very careful, and your code has to be very well tested before it lands.
Just to Ian's point, just to elaborate a little bit more, we take that responsibility for innovating out in front and then cleaning up the mess if we don't get it right very seriously. And that's caused us to do a lot of work in the last year, particularly around features like databases, where we tried something and it changed the discussion, and that's great. And we're excited about the way people are thinking about it now, but it does mean that we have to go back and do a bunch more work to make sure that when the standard does come down the pike, we get it right, and we go and we do the work to make sure that we are standards compliant as well as simply innovative.
And we've done that with, you can actually see a number of products that exemplify that. For example, with Gears, we were really out there trying to innovate and give offline access and offline data storage capabilities to web applications. And it was a great thing for Google to do. It was a great success. It showed that these APIs are actually worthwhile. And now there's a standard for how you do offline applications and how you do offline data storage. And so now we're implementing those standards. Same thing with 3D graphics. We put out O3D as an example for the need for rich graphics capabilities in the web browser. And now we, Mozilla Firefox and others, are collaborating on a spec called WebGL to give 3D graphics capabilities to browsers. And so we've deprecated O3D as a product in favor of WebGL. So we are committed to standards and to making sure that when we do something, we do it in a way that's good for the web. We take in feedback from the web community to help build up a standard, and then we support that standard going forward. Go ahead.
Yeah, so this is related to all of that. One thing you didn't mention is Websockets. And that protocol is kind of, by Mozilla, said they wouldn't push it at least until there's a little bit more standardization around that sort of API. I wonder what the status of that is, if you guys are planning to sort of solidify that. Just talk about it a little.
Sure, so I can definitely speak to WebSockets. I can't speak to Mozilla's shipping plans because I don't represent Mozilla, but suffice to say that we've had a number of lunches over beer with Mozilla to talk about WebSockets. There was a lot of beer. In terms of the WebSockets API itself, it's somewhat interesting in that it started off in the WhatWG working group. So Hixie wrote the first draft, recognizing the need to have bidirectional communications between a client app and a server. So for those of you who aren't familiar with WebSockets, today you can use hanging GET requests and a bunch of posts to effectively have bidirectional communication from your web app to a server. This has a number of downsides, namely each time you send something to the server, you have to send all of the headers. So if you want to send a 1-character update saying the user just pressed A, that can blow up to easily a kilobyte. WebSockets is designed to provide a long-lived connection that's bidirectional. So either the app or the server can send data, and there's a small amount of framing around that data, but you don't have all the headers each time. So this work that started off in WhatWG is now split between WhatWG, W3C, and IETF. IETF is now contributing in terms of the actual protocol, the wire format, how the data appears on the network. And there's a lot of changes being made right now. At Google, since we do have this frequent release cycle with Google Chrome, where we're shipping a new build every week to the dev channel, we are trying to stay on the tip of tree of that specification. So we're in the process right now of implementing draft 76 for WebSockets. We're going to ship that. We already shipped draft 75 in a previous version of Chrome. And we think that WebSockets right now is at a point where there's not enough people using it right now that we're worried about shipping breaking changes. So we are staying on the tip of that specification and continuing to ship the latest version. Obviously, we'd like to see it solidify, but we don't see it as a problem as of yet. And so we're going to continue to contribute to the protocol development and ship a client based on the latest version of the protocol.
Great, thanks.
It's on the block for Firefox 4.
So, related to that last answer, I know that Google's also been having some efforts to try to speed up the rate of communication, get around from the HTTP protocol. This WebSocket solution, will that be able to embrace that solution that Google has been proposing that will double the speed, I think, or so, is what's been talked about?
Yeah, so I believe what you're referring to is called Speedy, which is designed to take HTTP and make it much faster to load a web page with many resources. Speedy and WebSockets are in many ways sort of orthogonal. So Speedy is designed to take an entire page with a bunch of resources, like hundreds of images and CSS files, and allow that to be delivered to the client in a much more efficient manner, so much faster, primarily targeting latency. WebSockets is not about loading the entire page. WebSockets is really about replacing the use of hanging gets and post requests to do that bidirectional communication back and forth between the web application and the server. So while Speedy can be used to speed up the load of that web application, WebSockets is designed to make the communication of that web application and its server more efficient. So the two are sort of orthogonal in that respect.
It is worth noting that Speedy defines an opening to a server that's stateful. So you do get a bidirectional stateful communication channel, and WebSocket will be able to run over that, but that's again a negotiation that both the client and the server will have to make once clients and servers have both Speedy and WebSocket implementations.
Hi, I'd like to get you guys' thoughts on WebGL, what the status of it is, and kind of where Chrome stands in relation to it.
So the status, we're now shipping it in nightly builds of Google Chrome. I think we turned off the flag on that. I'd have to double check. You can see a lot of demos that will actually run in a dev channel build of Google Chrome. So we're definitely happy with the progress that's being made. We're not quite done yet, but I think it's safe to say that WebGL is something that we support, that we're happy to see continued development on, and we will continue to develop and support that specification.
By the way, this is another good one that sort of follow on to the previous, the earlier question about what's harder to do than you might expect for us. WebGL is one of those things that it sounds really straightforward. It's like, oh, it's just a 3D API, and my desktop OS has been doing that forever. But partly because of the nature of Chrome's process model and security system, it turns out that doing 3D graphics in a sandboxed rendering process is quite challenging, and especially if we want to maintain the performance and fidelity. It's that's been a lot of work to get right, and all that's starting to come together. And the nice thing about that is now that we're sort of getting all this accelerated 3D rendering working in this sandboxed model, you're going to see us being able to do more exciting accelerated graphics and speeding up Chrome along a bunch of different lines that you haven't seen us do yet.
There's active work right now, for instance, on hardware accelerating CSS transforms. So WebKit-based CSS transforms in Chrome will eventually be able to be hardware accelerated because of that same work. It is very difficult to get off the ground with a new system like this, but it pays off.
Hi, so this is, you mean, is it also for accelerating to the composition of the layers in this level of the, in this topic? Is also, are you guys working to accelerate the 2D graphics, let's say, like the 2D layers, like the Internet Explorer 9 is doing?
Yeah, we're also working to accelerate 2D graphics as well.
And are you guys planning on doing any work with the audio tag, like the work that the Mozilla guys are doing?
We support it, yes.
No. Yeah. But to be able to send data to the buffer and get data to the.
Do you mean the
buffer.
Mozilla?
Yeah.
The extensions to the audio tag API that Mozilla has offered so far.
So I'm not sure about the Mozilla extensions to the audio tag. We are working on another audio API that will actually grant you positional audio capabilities. So this is an API where you can not just construct audio on the fly, but you can also control effects such as position, directionality, reverb, the whole sort of line of audio controls that you would expect from something like DirectX Audio API. That level of capability we're looking to expose in the browser. And that work is happening in WebKit. There's a specification being worked on by one of the engineers at Google for that. So we are taking audio seriously. I unfortunately am not familiar with the exact extensions to the audio tag that you're referencing, but I can tell you that we do take very seriously the requirement to be able to build up audio on the fly, as well as control things like positioning. So not just playing back a simple audio file, but actually generating an audio stream on the fly and controlling the position of that audio.
And also, do you think you guys have reached the limits of the canvas tag, like the speed that you are drawing stuff, or in order to draw pixels and geometry?
So the question was, have we reached the limits of the canvas tag in terms of speed? And I think
no. Very briefly. So the canvas tag today uses a single array exposed to JavaScript that you script, right? Yeah. And then when you have drawn commands. Some things are going to continue to get faster. So V8 is continuing to get faster, and we're excited about how much faster it's going to be in the near future. So that aspect of canvas performance is going to continue to improve. There's also work happening right now, both in part due to some great proposals from Mozilla around typed array, which is a binary array subtype. And that work is sort of spilled over into the TC39, the ECMAScript working group, and is being actively considered sort of as we speak. And so a binary array type in JavaScript as a language will help us sort of accelerate some of those use cases as well. So where that goes, you can imagine, I think there has been work in the past and proposals on mailing lists for moving canvas processing out to worker threads, so getting it off of the main thread and maybe onto a different CPU. That's exciting as well. So there are other opportunities for us to accelerate it, and sort of, as canvas performance becomes a limiting factor, I think you should expect to see us exploring more of those.
Okay, thank you.
By the way, one other thing I want to mention about performance, and we're obviously very passionate about making the browser faster in all aspects, but some of the newer features of the web don't have a lot of use cases out there yet. And so we don't necessarily know where the limits are and where the problems are. So what we always encourage people to do is don't just assume that something is the way it is and that that's a limit. If you see something that feels slow, file a bug, express it in the form of a benchmark. It turns out if you put a web page out there that that'll spit out a number, that says, your browser runs this thing with a score of 42, and this other browser runs at a speed of 78.
We'll beat them.
Yeah, we'll beat them.
Well, you should first expect browser vendors to argue over whether or not it's a reasonable measurement. But once they do, they'll also at the same time be accelerating that test case so that they look good on it as well.
Yeah, exactly. So the thing that's interesting is if you have a web app and your web app feels slow for some reason, take your web app and consolidate it down to a benchmark. Publish that. And you'll have browser makers competing to make your web app faster. Trust me, it works.
So I work with a lot of embedded and resource-constrained hardware, and it seems like there's a potential for a lot of overlap between Chrome OS and Android, and I was wondering if someone on your team could speak as to which hardware maybe Chrome OS is more targeted towards versus Android.
Yeah, I can answer that. Right now, the Android team is focused on handsets. The Chrome team is focused on small form factor laptops, netbooks. It's pretty easy to see that there's there's some place where those two things converge, just looking at the trends and looking at iPads and things like that. And then, of course, the next question is, well, which one of these things is going to run better on those devices, where it's like a touchscreen, so it kind of seems like Android, but it's a little bit bigger, so it kind of seems like Chrome, and you want a more powerful browser. And I think the truth and the answer there is we don't know. We have two open source solutions out there trying to be the best solution for popular use cases today. And I think both of us will explore, how far we can take those different approaches. Both of them have their pros and cons. Both of them have, different targets right now. But, we'll see. We don't know, and I think that's a good thing. We'll have to see which one pans out. We'll have to see which ends up supporting those use cases well. We'll have to see which of these devices ends up being popular with consumers and important for us to nail.
Thank you.
Hi, I know we talk about a lot about performance in Chrome, and V8 is just incredibly quick. I've been pretty thrilled with that in my web application. But with that continuing to improve, what do you think is the future of the native code execution in a browser that also is being developed here at Google?
So I think that native code execution is important for two things. One is raw performance and speed, and I think that we are going to continue to increase the performance of V8 and give you faster JavaScript, but there will eventually come a point where you hit a level, where as a language, JavaScript is not going to be as fast for certain types of operations as native code would be. So I think that there's certainly a use case for native code for certain types of operations. For instance, every time you want to access a JavaScript object in V8, you're going to have to make sure, is this object still the same? Is this function still valid for this object? Is it at the same address? That's going to add some overhead. So native code where it's compiled in advance will have an advantage there. But I think one of the other big advantages for native client is not just in terms of performance, but realizing that there is this huge wealth of already existing code in the wild that is not JavaScript. So if you look at games, for instance, there are years and years that have been spent developing things like physics libraries and graphics engines for games. These would be very difficult and time intensive to port over to JavaScript. But if you could compile them and run them in C in the browser, you would be able to immediately take all of that work and port your application to the browser. So something like a game that had been written for iPhone in C++ or Objective-C could potentially, if you have support for those libraries and for native code, could potentially be run in a browser with a minimal amount of effort. So I think that that's another advantage to approaches like native client. It's not just about performance. Performance is a huge benefit, but you also get the benefit of being able to take advantage of existing code bases.
Maybe a different framing is to think of it in terms of effort versus outcome. And if you can't run native code, there's a cap on what sort of outcomes you can achieve per some level of effort, right? And so that transition point from I can do some simple HTML and I can start scripting it with JavaScript. If you're going to hit this thing up here where you can't sort of deliver that rich sort of game-like 3D world experience, which just doesn't have a semantic meaning as a document, you need to go, right? You need to keep going, and the web needs to deliver that to you. And so we think of our job as browser vendors as giving you full access to the platform in a way that's useful, easy, safe, and scales with your effort.
Cool. By the way, just one other follow-on. We've mentioned this a few times, but I think it's worth sort of combining it a bit. Is we've referenced that something will be useful for games, and the reason we keep bringing that up is because we think it's an important thing to really enable full fidelity entertainment, via the web. And so that means audio, video, 3D. That means high performance. That means dealing with existing code libraries. It means providing people a means to monetize, to sell these games, where maybe advertising might not work. These are all things that we think are connected.
For people that might want to aspire to be on a Google Chrome development team in the future, what experience or how did you guys end up being on this team?
I got a call from that guy.
Yeah, so there's a bunch of different skill sets that we look for in the team. We have, on this panel, we have represented people who are engineers and also product managers. Ian came to us because we were looking for somebody who understood security very deeply. He was doing some work, he was working on a PhD, and we stole him out of his PhD program because we needed a security expert on the team to fill the PM role. So, if you know a lot about web technology, that's pretty good. If you know a lot about browsers, that's pretty good. The engineering, maybe you guys want to talk about engineering.
I mean, the engineering philosophy, there's a lot to read out on the net, so I won't talk about it too much here, but the general Google hiring philosophy applies to Chrome, and which is that we do like to hire generalists, people who can do a lot, who can wear a lot of hats, who can see the big picture, and who aren't afraid to dive into code at any level of the system. So that seems to be a guiding principle. There's a lot of stuff about challenging interview questions and being able to answer complex coding things. But really, if you're a good overall engineer, can code in C++. Unfortunately, that's what we're coding in for Chrome. That's a good start. One other thing that just the Chrome, you have an advantage if you're interested in getting in the Chrome team versus just becoming a generic Google engineer, is that it's an open source project. And we really love external contributors. It's not often that you get people volunteering to help you do your job. And it's really humbling, actually, that we've created something that people are passionate about and really want to get involved with. But if back when I went to college, open source was just getting going, and there weren't as many opportunities. And what I'd recommend any aspiring, developer to do is jump on an open source project. Yeah, you're not getting paid for it, but this is great experience, and we welcome contributions. There's a guide about how to get started, how to build it. There's even a set of bugs that we have tagged saying help wanted or good starter bug, that are good places to get going. So if you really are aspiring and interested in building and getting involved in Chrome, we have hired people who came on as contributors to the project, and I'll tell you, there is no better interview than the proof that you actually contributed code and can have people on the team vouch for you. So.
This isn't unique to Chrome, by the way. I've worked at lots of other companies where if you could walk in and say, I'm a committer at Apache, that buys you, all the interviews before lunch are sort of cut off, right? It's not true at Google, but generally speaking, if you're looking for advice in terms of how to get hired anywhere, I'd suggest that you find something you really care about and go work on it in an open source project. By the way, is Mohammed here? I know he came out for I.O. He might not be in this session, but one of our open source committers came out and he visited the office. I think it was yesterday he was walking around, so it was nice to meet him in person. There's a lot of people out there who we communicate with on a daily basis who we've never seen, so.
Sure, and by the way, from all around the world, one of our most prolific and early open source contributors was from Poland, and he even though he's working on his PhD, he contributes tremendously, even in his spare time. So there's a lot of opportunity there.
And it's worth pointing out that we do have offices all around the world, not just here in California, but all the way out to London, Tokyo, and Russia as well.
So I guess the point is that we need help. We have way too much stuff to do. Please help. And there's no part of computer science aside, I think, from artificial intelligence and large-scale storage that we don't touch as the Chrome team. So.
Hi, I have two questions. The first one is, we have done a lot of benchmarking between the browser on Android and, Chrome browser, like SunSpider V8 benchmark, and I'm talking about the Android Eclair release. It's significantly slower than Chrome. So can you comment on whether Chrome can run on Android, or whether there would be plans, and how you plan to fix the gap?
So none of us are on the Android team, but we do talk to them, and we do share a lot back and forth. So take what I say with a little bit of a grain of salt. We share a lot of resources between in code. Android and we both use WebKit. Android is now, I think with Froyo, started to use V8. and also using Chrome's network stack.
Okay.
So we're sharing more and more each day. And I think that you're going to see that their performance and ours, get closer and closer over time. So on the browser front, we do collaborate quite a bit. I think, as Ian was saying earlier, we do have different constraints. On the desktop, we've got, we can pretty much assume, people have a lot of memory, a lot of RAM, but, on Android devices, you can't. It's much smaller footprint in general. The other thing that you've got that's a problem on Android that people don't really realize is that actually the flash storage is quite high latency. People think of flash as being faster, but it turns out that writing to flash, especially the type of flash that's in phones, is pretty slow. And so you have to be careful about how often you write. So even simple things like dealing with cookies. I know the engineer who worked on the cookie system for Android, and she was complaining to me about how trying to write to the database these cookie changes was killing their performance. This was a long time ago. They fixed some of that, but it was they had to come up with tricks and ways to avoid having to write too much. So we're always going to be a bit different just due to the constraints and the types of hardware that we're running on, and it's not really fair to do a strict apples to apples comparison there, but conceptually, assume that they're getting closer and closer over time.
Okay, great. Second question is, can you comment more on the video standards for what Chrome browser would be using now that VP8 has been announced? Which do you think would be more standard, H.264 or VP8, and how does Flash play into it?
So we did announce this morning in the keynote support for WebM, which is VP8 plus Ogg Vorbis as the audio in basically a Matroska container. We're obviously going to support WebM. We're already supporting H.264 as well as Ogg Theora. I think that right now it's a bit early to say whether we're going to make any changes in terms of discontinuing support for anything that we're currently shipping. I think right now we're putting a lot of focus into making sure that WebM is performant in Chrome and that we get hardware support for WebM, and we're trying to make sure that that's a great experience. And once we have more experience, more data on how that goes and what the adoption is, at that point we'll look to see what we're going to do with respect to the other codecs that we're currently shipping.
Okay, thanks.
Why is it unfortunate that you guys use C++?
Oh, it's not. I was joking.
Oh, really?
It's fast, and we need Chrome to be fast. Speed is what we're going for at every point. On the other hand, C++ is a very large language. It's difficult to know all of it, so there's a very high bar to getting going and getting started. I didn't mean that as a slight to C++.
But if you're a wizard at Valgrind and you love finding memory bugs, definitely go to google.com/jobs.
Yeah, I think that's the biggest thing is that C++ is, we wouldn't have chosen anything different, even in retrospect. It's the right tool for the job. However, with great power comes great responsibility, as they say. It's a dangerous language, right. And so as a result, we have to be very careful. Very early on, we used Purify pretty heavily because we were deeply paranoid about the kind of bugs we know were going to happen. And once Linux and Mac came online, getting Valgrind, we helped sponsor the Valgrind Mac port because we really, really wanted to make sure that we weren't introducing new memory bugs. This is an area that I think if you're doing C++ development, C development, you cannot be too paranoid about this in your development process. And building it into your tools and into your build process is an important thing to do.
It's also in the architecture with the sandbox model, right? That paranoia goes all the way down.
And just how's it as developers, being somebody that's pushing standards, you guys are getting everyone to join a bandwagon, and then you got people lagging behind, like Internet Explorer, and as developers, we'll love to develop on and push all this stuff, but then we also have to support the weak chain.
I would actually turn that question around and ask, as an application developer, not as a browser developer, what's it like to have certain browsers that are lagging behind, and what can I do as an application developer to change that?
I mean,
So-
that's definitely something like how do we, what can we do to help you
Build
guys?
great apps. Like,
Also-
I'm not kidding. The best way to do it is to build apps that are absolutely awesome, get them to work great, show that these functionalities that you want to take advantage of can actually let you do awesome things. And if you have a huge app with a huge number of users, I don't work for Microsoft, so I can't say I guarantee it, but I would expect that if you build it, they will come.
So I work on Chrome Frame, which, for those of you who may not be familiar with it, is a plugin for Internet Explorer that puts Chrome's rendering engine inside of IE. I feel your pain, right? I think that's the easiest way to say it. I worked on a JavaScript library before I came to join Google, and that was sort of plan B. Plan A was browser competition gets us new features everywhere faster. Browser competition should always be plan A, right? Part of the reason that specs work so well is that they get every other browser vendor on the exact same page that we are, and hopefully it happens very quickly, right? We work on something, we build a spec where we contribute to a spec, we find a spec that already does what we want, and we implement it. And then hopefully everybody else comes along very quickly. There's some chunk of the user base who may not be making informed choices about their usage of browsers. And so I acknowledge that we have an economic problem here, where we have to bring many users along who may not know that they have choices and may not know how to exercise them if they do. So Chrome Frame is our sort of interstitial answer here. We need a way to help organizations and users come along for the ride, get the new applications where they may not be able to make choices about getting a different browser for themselves. But hopefully that's a way station on the way to getting people to use better browsers in general, and getting people to have browsers that auto-update, right? One of the best things, one of the most wonderful things I've seen in a very long time was watching the browser percentages over the summer of 2009, when Microsoft turned the auto-update switch for IE7 to IE8 on as a high priority update to XP and Vista. You could watch the percentages flip in a matter of months. This is really great news. This is good stuff. That means that auto-update works and that browser competition works. We get great new features and we get them faster when we have browsers that auto-update. So,
By the way, I think that you've asked the question that is almost by definition the reason for Chrome's existence, which is that browser development wasn't happening fast enough. And standards weren't moving fast enough, and performance wasn't moving fast enough. These were things that were not good enough. And so part of the whole purpose of Chrome's existence was to light a fire for the whole industry. And I hope that people, that see that it seems like that's happening. And we're not done. We think that the fact that, if you watch, like, for example, just the performance graph of V8, from when we came out to where we're at now, the delta between version, Chrome 4 and Chrome 5 was, as big or bigger than the performance leap from the previous release. And basically, meanwhile, all the other browser makers have been, slowly catching up, and we don't want them to think, okay, now I've gotten as good as Chrome, I'm good enough, because we want to be at that next level higher to keep pushing it forward. And so this is going to be on performance, this is going to be on standards and capabilities and features, and on any axis that we can think of to make browsers better.
Thank you.
So when a bug comes in, question was, what's our stance on security? What happens when a security bug comes in? So there's a number of ways that security bugs are reported. There's either the bug tracker, where you can file a bug as a security bug. We also get reports to security@chromium.org and security@google.com. When those come in, a number of people, myself included, get emailed as a very high priority email to go take a look at that bug and see, A, is it valid? B, can we reproduce it? C, how serious is it? And we then go about trying to understand the bug, making sure that we can reproduce it. If we can reproduce it, understanding, is this something that's exploitable? If so, how exploitable? Does it just crash the browser? Does it let you execute arbitrary code on the user's computer? If so, does that code execute within the sandbox? Does it execute outside of the sandbox? So we very rapidly understand the bug and the severity of the bug. We then develop an update, and because of the auto update mechanism, we can push it out. To all of our users automatically. You might not see it immediately disclosed. There's good reasons for that. One of them is just the delay in updating. We don't update overnight. We do sort of do a staged update over a few days to make sure that we're not going to blow anything up. But another reason is that a lot of times we find bugs in shared components. This could be in the WebKit code that we use for rendering. It could be in a library that's used by not just Chrome, but other applications. So we want to make sure that we're responsible with that information, that we report those bugs upstream, and give other users of that code a chance to update their applications as well before we just open that bug up to the public. So we are very careful about making sure that we update as quickly as we can, but we also want to do that disclosure of the security bug in a responsible manner. So we're not trying to hide the fact that we had a bug. We're not trying to not disclose it so that we look better in some bug timing metric. It's really about doing the right thing and making sure that we aren't putting any additional users at risk.
So another related point I'd make is we're not just reactive on the security front. We're not just waiting for bugs to get reported and then fix it. We have a team of some of the smartest security vulnerability generators that I've ever seen. These are the sort of people that are really good at finding exploits and things, and they're frightening. I mean, some of the bug reports will, it's bizarre.
Once you understand it, it actually does hurt.
So we have these people who are actively trying to break Chrome all the time, and on the payroll trying to do things. And one of the things that I think that we do that I'm very happy about the way we do it is that when they find bugs, we disclose those bugs as well. The fact that they were discovered internally doesn't mean it wasn't a security bug. It doesn't mean it's something that we should be able to really hide or obscure from people. So we'll publish that as well when we fix that and let people know that there was a bug in a previous version. We tracked it down and whatever, so you can see those things.
We also have a bug bounty program, so if you find security bugs, we want to reward people for disclosing them responsibly, and we'll give a little cash to the people who do that and give them a little acknowledgement too. So hopefully that's inspiring people and encouraging people to do the right thing with bugs.
Is the development of the Go language in any way to go help deal with the problems encountered with memory issues that have been discovered by your team?
It doesn't help us, but I'm hopeful that the browsers that come after us could use something like Go.
So one thing that I will say is when we created Google Chrome and we decided what rendering engine to use, it was very important for us not to create another rendering engine. We didn't want to, and this is not to say there should never be another rendering engine, but when we looked at our options, we felt that if we created another rendering engine with a different set of compatibility issues, at that time, it would not be a good thing either for us or for developers. So we were very keen to use an existing rendering engine, which also heavily influences the choice of language that you're going to use. Because if your browser and rendering engine are in two different languages, you will have some fun.
You've mentioned a few times about your development process, working on an open source project, dealing with external contributors, staying with the trunk. Can you comment on how that compares with the closed projects within Google? Is it roughly the same with the apps guys or the mail guys? Or?
I think parts are the same and parts are different. Google has a very strong culture around things like code coverage and automated testing. So a lot of projects, and code review. So a lot of projects in Google share that philosophy of making sure that there is something like a continuous build so that when you check in a change, you can see did that change break the build? Did I just hamper the productivity of other developers? But there are some unique constraints that we face in an open source project, especially when we're developing things like the Chrome Web Store. Obviously, when you start checking in changes like that, everyone's going to see. So I think there's a lot of shared culture between the Chrome team and the rest of Google in terms of common engineering practices, code review, automated testing, but I think we also face some slightly different constraints.
Yeah, I mean, the project originated, at Google, so I would say that more that the Chrome team was influenced by Google's existing engineering practices rather than, the other way around, right? So the code, the code coverage, the testing, even the frequent release process, I think is in part a reflection of the fact that Google is mostly a web company, right? Mostly used to this, being able to push, right away, today, this week, as opposed to being on monolithic yearly release cycles, and that we wanted to do that too. So I think the underlying culture at Google definitely influenced how we wanted to do it, even though we were going to be open source, and that was going to make us a bit different. Thank you.
Any other questions? Yes.
I can take a quick shot at it. Oh, sorry. Yes, of course. So the question was, we have a challenge because we have so many different dependencies and we're adding new features all the time. So how do we manage the source control between the trunk version, which we released the dev channel off of, the beta channel, which is sort of like the broader update, it's probably not going to be on fire version, and then the stable channel, which is it's definitely not on fire. We have a couple of other axes which are important. First, we have external code bases. So we work very closely with the WebKit community, and that means that we try to stay as close to the WebKit tip of trunk as possible, but if we have to land a patch on both sides, we have to commit it in both places and keep those in sync. We use external libraries, things like Skia, which is our drawing library on Windows and Linux. Skia is the graphics library that's also shared by Android. And that component is also a third-party component. And we've actually taken that opportunity to break out some other components as well and turn them into third-party dependencies with their own sort of Google code sites and their own source control systems and their own revision systems. So we have a lot of dependencies in a lot of places and some complexity about rolling revisions. So we've built some tools. I mean, that's sort of like, I think, the Google engineer way to do things is you go and you build tools to make it happen. So instead of having just raw subversion, we have raw subversion with a wrapper called gclient and GCL. GCL manages change lists, and gclient helps us sync revisions to third-party dependencies so that we can check in a file, sort of like a subversion externals, that allows us to lock to a particular revision of an upstream or third-party package. And so when we say we want to get a new version of WebKit, we change the revision number of that third-party upstream dependency in the deps file. We call it a deps roll, and then we run it through the continuous builds, and then everybody gets it. So that's sort of the general process, is that we manage those dependencies by sort of keeping them at a little bit of an arm's length, but trying to stay up as quickly as possible with them. In terms of how we make releases, there are branches. There are 2 branches, usually alive at any point in time. There's the dev channel, which is trunk. There's the beta channel branch, and then there's the release stable branch. And we selectively roll patches in from trunk down to those 2 branches so that they churn much less frequently than trunk does. Does that answer the question? Great, yeah.
One additional follow-on I'll say is that the core part of our release is the dev channel. So beta and stable are really just patches, mostly security bugs, little incremental bug fixes. The philosophy, the way we describe it, is called trunk stable. So what it means is that the trunk of our source repository should always be buildable, should always be in a reliable, usable, shippable state at any moment in time. Now, we're not perfect about that, but we're pretty close, actually. And so what that means, in order to be trunk stable, it puts a bit more onus on each developer with each check-in to think about how your check-in is going to keep it stable. So for example, when Ben Goodger, our UI lead, landed wanted to redesign how the tab system worked, the underlying drawing and user interaction mechanism, you could imagine that was going to be a pretty destabilizing change, and it's pretty hard to land that in a trunk stable way. But the way he did it was to essentially have to land a completely separate fork of code that duplicated much of the logic that was in the other one. And so have two separate versions of the code simultaneously in the tree that were controllable via a command line switch. So basically, you land the new feature, and it's behind the switch. By default, you get the old behavior. If you use the switch, you get the new behavior. As you iterate, the new feature gets more and more stable. You start to feel better about it. At some point, you flip the switch the other way. So you still have a switch, but it now is, give me the old behavior, please, type switch, because you broke something. But you're trusting it to be stable enough. But because you've got them still both in there, it's easy to revert. It's easy to say, oops, I broke something. Let me quick switch it back for a few revisions while I fix it some more. Now we'll try it again. And so it's more work for us as developers, but in the end, it's actually a huge net productivity gain. Because if you've ever worked on projects that don't have the trunk stable philosophy, you get into a state where people can't build, where the tree is broken for long stretches of time, where regressions creep in and no one knows where they started, and trying to track those down becomes a nightmare. Or you work on large feature branches for months at a time that suddenly land in one gigantic merge and that suddenly destabilizes everything. So while it's more work for each individual patch, the net effect is a big win.
So I see our clock in the back has actually hit 0. I'm supposing that means we are probably out of time. So I'd like to take this opportunity to thank everyone in the audience for coming, for asking a great set of questions. Thank you all so much. It's great to get this feedback, and I hope you enjoy the rest of your time here at Google I/O. And we'll probably be out in the hall for a little bit if you have any other questions that you want to ask. Thanks.